Okay, let's dive deep today into OpenAI's newly announced GPT 4.1 models. We really want to explore what they mean for the world of programming.
Absolutely. It's a significant move.
Yeah, and for this deep dive, we've gathered info from, well, all over. YouTube channels like Coder House, Education Intelligentsia Artificial, Middle Line.
Articles, too, right? Fairware, Reddit threads, Pasión por el Espacio.
Exactly. Chile, Ecuador, Uniandes, Equavisa, even app syncing guides, a whole range.
Hmm.
So our main goal here is to kind of pull out the key insights from all these different places. We want to give you a clear, concise view of what these new models actually mean for AI and, software development.
And it's quite interesting because OpenAI didn't just drop one model. It's a whole family, isn't it?
Right. There's GPT 4.1, the main one, but also GPT 4.1 Mini and GPT 4.1 Nano.
Yeah, and that Nano one is positioned as the smallest, the fastest, and crucially, the most economical option they offer now.
That's a key point. And OpenAI is making some bold claims, saying this new generation is better in, quote, almost all aspects compared to GPT 4.0.
Uh-huh. What's really grabbing attention, though, is the claim that in many areas, these models actually match or even outperform what people expected from, say, a GPT 4.5.
Yeah, that's the head scratcher, or maybe the exciting part.
It is. And if you look at the context window, the change is pretty dramatic. All three GPT 4.1 models can handle up to 1 million tokens.
1 million tokens.
So
It's huge.
it's massive, 8 times the 128,000 tokens GPT-4 offered. Just picture it, you could potentially feed it something like 8 full copies of the entire React codebase.
Wow, that fundamentally changes how AI can assist with large projects, doesn't it?
Completely. The scale is just different.
Okay, let's break this down a bit. Each model has its own strengths, yeah.
Exactly. GPT 4.1, the flagship, is designed for those really complex tasks. It's got a strong focus on coding, generating functional code, handling diff formats, exploring repositories.
And it's meant to be good at following precise instructions, plus that long context, of course.
Precisely. Then you've got GPT 4.1 Mini. It seems to be aiming for that sweet spot.
The middle ground.
Sort of. It balances several key things. Decent speed, about 40% faster than 4.0, apparently. Intelligence that, according to benchmarks, beats its predecessor. Lower costs. And importantly, it still gets that million token context window.
So a versatile option, maybe?
That seems to be the idea. And then
Yeah.
there's GPT 4.1 Nano.
That's B-Demon.
And the budget option. It's supposedly 50% faster than 4.0 and comes in super cheap, like $0.12 per million mixed tokens.
12 cents. Okay.
Yeah, so it's ideal for things like code auto-completion, classification tasks, extracting info from long documents, and again, it keeps that million token context capacity.
Incredible consistency on the context length across the board.
It is. Now, to put some numbers on these improvements, the benchmarks are quite revealing.
Right, let's get into those.
Okay, so on SWP Cheat, which tests software engineering skills, GPT 4.1 hit 55% accuracy. Compare that to 33% for GPT 4.0.
That's a significant leap.
Huge. And surprisingly, it even outperformed models like OpenAI's own O1 and GPT 4.5, which scored 38%.
Wow, okay, so 4.1 is really stepping up. What about Mini?
Mini also showed a big improvement. It reached 24% accuracy versus just 9% for the old GPT 4.0 Mini.
Okay, consistent improvement there too.
And it gets more interesting. On the EAR Polyglot benchmark, that's the one measuring multi-language programming skills, GPT 4.1's performance difference compared to 4.0 has basically doubled.
Doubled. What does that mean in practice?
It suggests much higher efficiency for developers working across different programming languages, could really speed up development cycles.
Right, less friction, switching between languages, makes sense.
Then there's the Scales multi-challenge eval. This looks at how well the model follows complex instructions over multiple turns.
Okay, like a long conversation.
Exactly. And GPT 4.1 showed a 10.5 percentage point improvement over GPT 4o on that one. It suggests a better ability to really grasp and execute detailed instructions, which is vital for complex coding tasks.
Better instruction following is always good news. And what about the classic needle in a haystack test?
Yes. All three models, including Nano, successfully found the specific piece of text within a massive corpus up to that million token limit.
Even Nano. That's impressive for the smallest model. Shows real capability in handling large amounts of data.
Definitely. It's crucial for analyzing extensive software projects or documentation.
Any other standout benchmarks?
Well, there's OpenAI MRCR, designed to test distinguishing similar items in a long context. GPT 4.1 outperformed GPT 4o there, too. It suggests a finer understanding of subtle contextual information.
Which could mean more accuracy in code generation and understanding.
Potentially, yes. And even in understanding video content without subtitles, using the Video MME benchmark, GPT 4.1 hit 72%. That's a 6.7-point increase over GPT 4.
Video understanding, too.
Yeah, and they specifically mentioned GPT 4.1 Mini standing out in multimodal reasoning and intelligence tests, which is remarkable given its smaller size.
So these benchmark numbers aren't just abstract scores. They translate into real-world benefits.
That's what the early reports suggest. Windsurf, which is an agent-based IDE, reported a 60% improvement in their internal tests using 4.1 compared to 4.0.
60%, that's huge.
It is. They also noted that the new model reads 40% fewer unnecessary files, modifies 70% fewer files, and is 50% less verbose in its output. More efficient, more targeted.
Less noise, more signal. Got it. Any other examples?
Yes, several. BlueJoe saw a 53% accuracy increase in complex tax scenarios. Hex reported nearly double the improvement in tough SQL evaluations.
Double.
Thomson Reuters achieved 17% better accuracy reviewing multiple documents. And Carl reported 50% better performance extracting detailed financial data from long documents.
These are pretty concrete gains in productivity and quality across different domains.
They really suggest a tangible impact.
Okay, let's talk about the cost, because performance is great, but price matters.
Right, and OpenAI has made significant cuts here. GPT 4.1 costs $2 per million input tokens and $8 per million output tokens. That works out to a blended cost of about $1.84, which is 26% cheaper than GPT 4.0.
A decent drop, and the smaller ones.
GPT 4.1 Mini is $0.40 for input, $0.60 for output, so about $1.42 blended. And Nano, the cheapest, is just $1.10 for input, $0.40 for output, landing at that $0.12 blended price per million tokens.
So significantly cheaper tiers available now.
Definitely. And a key point for developers, there are no extra charges for using that massive million token context window.
Oh, that's good. So you don't get penalized for using the main feature.
Exactly. Plus, they've increased the discount for prompt caching. It's up to 75% now from 50% before. And there's an extra 50% discount for using the batch API.
Making bulk processing much more economical then.
That seems to be the goal. Facilitate larger scale use.
Now, one piece of news that might have caught people off guard was about GPT 4.5.
Ah, yes, the discontinuation. OpenAI announced that GPT 4.5 will be removed from the API within the next 3 months.
Why are they doing that? Especially if 4.1 is only just matching or sometimes beating it.
The official reason is that GPT 4.1 offers similar or better performance in many key areas, but crucially at a lower cost and with lower latency.
So 4.1 basically makes 4.5 redundant from a cost-performance perspective.
That seems to be their argument. They also mentioned wanting to free up GPUs currently running 4.5 for future research. But they did say they plan to incorporate the valued qualities of 4.5 into future models.
Okay, so it's not entirely disappearing. Maybe its strengths will reappear later. So let's sum up the main advantages of these new models.
Sure. You've got substantial performance improvements across the board, significant cost reductions, especially with Mini and Nano, that massive long context capability, better instruction following, and 3 distinct models catering to different needs.
Sounds pretty positive. But are there any downsides or limitations mentioned?
A few things have been pointed out. Firstly, GPT 4.1 itself is currently only available via the ATI, not directly in the consumer-facing ChatGPT interface.
Ah, okay, so developers get it first.
Right. Also, users who built systems relying on GPT 4.5 will need to migrate, which is always some effort. And the usual caveat, benchmarks don't always perfectly predict real-world user experience. Plus, the initial announcement was apparently a bit light on details regarding safety and security aspects of these new models.
Important considerations. But you mentioned GPT 4o earlier. How does that fit in?
Right. The good news for general users is that OpenAI confirmed that many of the improvements seen in GPT 4.1 are being integrated into GPT 4o, which is the model powering the main ChatGPT experience.
So ChatGPT users will benefit from these advancements, even if they aren't using the 4.1 API directly, like faster responses, better capabilities.
Exactly. Things like image generation, speed boosts, better memory. Those kinds of improvements in GPT-4 likely stem from the same underlying progress we see in 4.1.
That makes sense. There was some confusion around the naming in the whole 4.5 situation, wasn't there?
Yeah, a bit. The emerging perspective seems to be that maybe 4.5 was always intended as more of a preview or an interim step, showcasing capabilities that are now more fully realized and productized in the 4.1 family.
Sort of like a beta test that got pulled once the polished version arrived.
Perhaps. It also seems to reinforce the strategy from OpenAI. having distinct models for the API, optimized for raw performance for developers.
And then a model for ChatGPT may be tuned more for like a nicer output and user interaction for the general public.
That could be it. Different optimization goals for different audiences.
And finally, on the availability front, it's being integrated into Copilot too.
Yes, that was confirmed. GPT 4.1 is making its way into Copilot, which significantly broadens the access for many developers and users already in that ecosystem.
Okay, so it's not just locked away in the API for specialists.
Not entirely, no. Its influence is spreading.
Well, let's shift focus a bit to ChatGPT integration and general applications. We've established 4.1 is mainly for devs via the API.
Correct. But again, it's crucial to remember that many of the underlying improvements are flowing into GPT-4o, the engine behind ChatGPT.
So users are already experiencing some of these benefits: better image generation, faster speed, improved context handling.
Precisely. It enhances the overall user experience.
And what really opens up possibilities is the potential for GPT 4.1 Mini and Nano to run on, say, edge devices or devices with lower power.
That's a very exciting prospect. The ability to run capable models locally or on resource-constrained hardware could unlock a whole new wave of innovative and more accessible solutions. Think offline AI, more private processing.
Yeah, lots of potential there. What kinds of applications are seen as prime candidates for using these improved ChatGPT-like capabilities?
Oh, the list is long. Virtual assistants could become much more understanding and responsive. Customer service chatbots could handle more complex queries effectively.
Education platforms?
Definitely. Personalized learning experiences. Also, mental health and wellness apps offering deeper, more empathetic interactions. Even entertainment apps could become more immersive and adaptive.
So if someone wanted to build an app using ChatGPT, what's the general process?
Well, the sources outline some typical steps. It starts, as usual, with defining the project scope and doing market research, then designing the user interface, UI, and user experience, UX.
Standard app development stuff so far.
Right. Then comes the back-end and front-end development, building the actual app infrastructure. The key step is integrating the ChatGPT API.
That's where the intelligence comes in.
Exactly. That integration gives the app its conversational and generative abilities, allowing for those smart interactions.
And then you'd add specific features, test thoroughly, launch, and maintain it.
That's the cycle. The sources even mentioned a case study, like building a customer service app, to illustrate how you'd go through these stages integrating ChatGPT.
Okay, that makes sense. Now let's look specifically at the impact on code generation quality and efficiency. There was a systematic literature review mentioned.
Yes, quite insightful. The review confirmed that large language models, LLMs like these, significantly improve the quality of the code generated. They also boost programmer productivity and act as valuable learning aids.
It's becoming a standard tool, isn't it?
Increasingly so. It was striking that something like 2/3 of the papers reviewed were published just in 2024. Shows how fast this field is moving, with the U.S. leading the research.
Wow. Very recent focus then.
Absolutely. And specific tools like ChatGPT itself, Codex, GitHub Copilot, they are widely recognized now as valuable for both learning programming and improving code quality.
Can they help beyond just generating snippets? Like structuring whole projects?
Apparently, yes. One example given was using an LLM to help structure the entire architecture for a Flask web application.
Okay, so more high-level assistance too.
And they can help break down code into reusable modules and functions, which is great for maintainability and testing. Plus, they can assist with integrating code with other technologies, like connecting to a SQLite database, for instance.
Making complex integrations easier.
That's the idea. Another benefit highlighted is their ability to generate code documentation automatically. And they can even act as code reviewers, suggesting improvements for efficiency or readability.
A virtual pair programmer, almost. But there's a catch, right? You can't just trust the output blindly.
Absolutely crucial point. The sources strongly caution that developers must review and verify the code generated by ChatGPT. One figure mentioned suggested only about 57% of code responses might be completely correct without needing tweaks.
So it's a powerful assistant, but not infallible. You still need human oversight.
Definitely. It's a tool, not a replacement for understanding. To get better results, though, there are prompt engineering strategies.
Like telling it its role.
Exactly. Structures like Role task format or context task format. Giving it clear context may be an example, defining the role it should play, and specifying the desired output format helps guide it more effectively.
Makes sense. Give it better instructions, get better output.
Beyond generation, LLMs also seem to contribute to better accuracy in fixing bugs and even detecting security vulnerabilities, so they can support software security too.
That's a significant benefit. But is there a downside, especially for learners?
Yes, a valid concern was raised about students potentially becoming too reliant on these tools. The worry is that it might hinder the development of critical thinking and fundamental problem-solving skills if they just ask the AI instead of grappling with problems themselves.
A potential crutch rather than a learning aid if overused.
That's the risk. But overall, LLMs are automating time-consuming tasks like summarizing code, fixing simple errors, identifying potential issues, which frees up developers for more complex work.
Improving overall efficiency.
Uh,
Okay, let's look ahead. What are the broader implications for the future?
Well, the consensus is clear. AI in programming isn't just a trend, it's a fundamental shift. It's here to stay and transforming software development.
Staying updated is no longer optional.
Pretty much essential for developers who want to remain competitive and leverage these powerful tools. You have to keep learning.
And this GPT 4.1 launch, it feels like OpenAI is also making a move in the competitive landscape, right?
Oh, absolutely. It seems like a strategic push to reassert their position and showcase continued innovation amidst growing competition in the AI sector.
And these new, more capable models, especially with the long context, what possibilities do they open up?
They really pave the way for more sophisticated intelligent systems and applications built around autonomous agents that can handle complex multi-step tasks.
We're moving towards more capable AI assistants and workers.
That seems to be the direction. It'll be fascinating to see how developers and companies actually start using these new capabilities in their workflows and products.
Is adoption happening quickly in businesses?
It's growing, definitely. But the sources also note that widespread adoption requires more than just the technology. It needs ongoing training and, importantly, a shift in mindset within organizations to truly embrace and integrate AI effectively.
Culture change is always the hard part. Okay, let's wrap this deep dive up. Time to recap the key takeaways.
Sounds good. So we covered the launch of GPT 4.1 and its three-model family, 4.1, Mini, and Nano. We saw the significant improvements in performance and that massive context window.
Right, and its availability primarily through the API, but also the integration of many of these improvements into GPT-4o, the engine behind ChatGPT.
We discussed the considerable impact on programming, boosting code quality, developer efficiency, and even serving as a learning tool, though with caveats about verification and over-reliance.
And we touched on the future implications, the ongoing transformation of software development, the competitive AI landscape, and the potential for more advanced agent-based systems.
So the question we leave for our listeners is this: how might you use this information in your own learning or your work? What new possibilities do these advancements spark for all?
And maybe a final thought to ponder. Given how fast AI is evolving, how can we all best prepare for the changes it's bringing, not just to tech, but, well, everywhere? What big questions are still out there waiting to be answered as this unfolds?
This has been our deep dive into the available information on GPT 4.1. We aim to provide an informed perspective and hopefully something useful for understanding what these new OpenAI models really mean.